It is winding down to some of the last few videos of pharmaceutical calculations with Dr. Dave. This one is talking about parenteral nutrition. Parenteral nutrition means we're giving nutrition by IV, or we're also going to talk about enteral nutrition, so giving it through the GI tract. But for parenteral nutrition, so these are people primarily that are not able to take something either because of conscience, they're not able to eat, or they have other issues. You have to give them nutrition through IV. The three main components of the macronutrients that we call the macronutrients that we have is amino acids, carbohydrates, and fats or lipids. So when we say amino acids, we're talking about the protein source. If I say carbohydrate, we give that in pharmacy by parenteral by using dextrose solutions. And we are already familiar with D5 dextrose, but there's other dextrose concentrations. And when we talk about lipids or fats, that's what we're talking about by giving them all through parenteral routes. So usually for parenteral nutrition, we also do the electrolytes. We do vitamins, minerals that can be injected into IV bags for these. But total parenteral nutrition is usually the terminology now that people use. TPNs you'll hear in hospitals. It's a TPN, it's a total parenteral nutrition. It used to be called hyperals back in the day for hyperalimentation. You can buy them commercially made, or you can make them in the pharmacy, depending on where you are. You might see that, or you may not see that. There are some stock formulas that they do have in case they can't make it, or it's at a nighttime where it would not be available. So we are going to do some calculations based on looking at the patient's needs, their parenteral nutrition needs. The first thing we're going to do is look at how do we calculate how much fluid the patient needs. And you will see, in general, everybody needs about 2 to 3 liters per day for a healthy adult. Now, of course, a lot of people who are going to be using this are not considered healthy. So depending upon the disease state that they have, they may require additional fluids. And therefore, it's important for us to estimate it. And everything we're estimating is for a 24-hour period. The loss of fluid, you can read through this, but you have two types, really sensible and insensible. Sensible loss is stuff you can measure. If the patient's vomiting or the patient's urinating, you can collect that and you can easily measure it. Insensible losses is that something you're breathing, you're sweating, it's coming off. There's really no easy way to collect that and to measure that in a clinical setting. Those are insensible losses. So an estimate of the patient's fluid needs is based on insensible losses. All right. We're going to be using, sorry, I have this day here. I don't know why that's there, but ignore that. But so what we do is we start off with estimating insensible losses, and then we add sensible losses. So we add anything that the patient already was, let's say, excreted or that we measured and replaced that on top of it. So what do we estimate for insensible losses? We estimate about 30 to 35 milliliters per kilogram per day. So, sorry, per milliliters per day. So this is how much liquid per kilogram per day you're losing without really noticing it. So let's use a calculation. Calculate daily fluid requirements in terms of insensible losses for FT. The 20-year-old male weighs 101 pounds. So in order to do that, let's convert pounds to kilograms. We're very familiar with that. We have, let's see, I don't know what that's there, so I apologize, like I said, but 101 divided by 2.2 is going to give us about 45.9 kgs. Okay? So that's my pounds, and this is my conversion factor, 45.9 kilograms is what the person is. The fluid requirements are between 30 and 35 milliliters per kilogram per day. So let's take the range. The first one is 30. This would be 30 mLs per kilogram per day. So if they're 45.9 kgs, the other one is going to be 35 mLs per kilogram, and the same weight that the person weighs. Apologize that my 9s are not connecting there. These are the 9s here. So this one on top is going to be about 1,377 mLs. The one on the bottom is about 1,605.5 mLs, right? So this is our range right here. The range between almost 1,300 to 1,600 mLs per day is the upper and lower range that a person would need estimated on their insensible losses. So if FT, which we know needs that range, they also produced 1,850 mLs of urine in 24 hours. So now what is their daily fluid requirement? Well, again, with the daily fluid requirement is taking what we have for insensible losses, which is what we calculated. It's either 1,377 mLs or it was 1,605.5 mLs, right? And we're going to add to that the sensible loss, which was 1,850 mLs of water, or I should say urine output that we did. And now we have a different range. Now we've got 3,227 mLs here, and we got about 3,455.5 mLs here. So now this is our range that we have for the daily fluid requirement. This one is just insensible losses. The overall range is how much they're excreting through all sensible and insensible. And this is the range of what we would have to replenish with. So that's the amount of fluid we want to give them per day. Next calculation is caloric requirements. The kilocalorie is the unit of measure that we're using for metabolism, that energy. Right? This is the numbers that we calculate are going to be called the basal energy requirements. This is the minimum amount just to maintain basic life. Right? To stay alive, this is the basic minimum energy requirement that you would need. And we are going to use the Harris-Benedict equation for basal energy expenditure, B. Basal energy expenditure. These are the equations. You have to memorize both of them. I'm joking. Of course, I'm not going to have you memorize them. That's useless to do. In this case, you should be able to apply them. That's the concept. Read through it, understand it. All right. So the basal energy requirement, right, is the resting energy need. So this isn't a person moving around. This is a person that's really not doing anything but just breathing, right? That's what the basal energy requirements are, right? And the basal energy requirements, the basic, you can say, is going to be adjusted, right, for higher things in terms of their activity or other type of stress levels. If you take the basal energy requirement, that big calculation we have here, and you can find out a total daily energy requirement by multiplying this number by two things. The activity level of the patient, and activity level for somebody confined in bed is 1.2. If they're out of bed and they're moving around, it's 1.3, times any stress factors that are there. If the person had surgery, if the person was a burn victim, or if the person had CMS trauma that was severe, you would also multiply by a factor of 1.3. Right, so it's like 20% more here, 30% there, and twice for burns. All right. So let's just utilize the equations. That's all this is. It's a plug and play sort of a scenario for looking at the energy requirements. So for basal energy requirement, let's look at this question. It says calculate the total daily energy requirements for a 58-year-old female who is 5 feet 3 inches tall, weighs 140 pounds. The patient has also undergone surgery, so they have that stress factor 1.2, but they are ambulatory. They have that activity factor 1.3. I was nice enough to tell you that 1 inch is equal to 2.54 centimeters because we're going to need that in the equation. So in order to get to total daily energy requirements, we need the basal. The basal for a female is here. This is the equation that we are taking. I am just going to plug the numbers in as we go. We need the weight in kilograms. So I'm going to say kilograms, or I should just say weight. Let me see. So before I can plug numbers in, I need weight in kilograms. The weight in kilograms is the person who weighs 140 pounds. And I'm going to multiply or divide that by 2.2, 63.63, or about 63.64 actually. So 63.64. We also need their height in centimeters. Height is in centimeters. The person is 5 feet 3 inches tall. And how do we get that into centimeters? All right, so we're going to do our 5 feet times 12, which is the number of inches in 5 feet, plus the 3 inches, 63 inches. Every inch is 2.54 centimeters, so I'm going to multiply by 2.54. I get 160.02. So 160.02 is the centimeters in height of the patient. And we need age in years. The age of the person is in years is 58. Why did I do all that? Because look at what we have to do. We need weight in let's do for the female. We need weight in kilograms. I need height in centimeters, and I need age in years. And we're going to multiply by those multiplication factors to get first the basal. I'm not going to do all the calculations out, but I will at least show you the setup for it. The setup is going to be 655.1. We're going to add that to 9.56 times 63.64, which is their weight in kilograms. We're going to multiply that, or add that to 1.85, which is multiplied by the inch or the centimeters, 160.02, minus the 4.68, and this is times 58, and 58 is their age right there, right? 4.6 minus that. If you do all that out for basal energy requirements, you get a BEE of about 1,000. That's a 1 out of 7, 1,288. 0.0954. This is kilocalories. Now we can add on top of that to get the total daily energy requirement, total daily, right? Total daily in the equation, we are going to take the BE and then multiply it each by those two other conversion factors. So we've got 1,288.0954 kilocalories. We're going to multiply that by 1.2, which is the factor for stress, and multiply that by the activity level of 1.3. It's going to give us about 2,009. Oops, sorry. Put some zeros there. 2,009.4288 kilocalories is their total daily energy requirement. All right. So 2009.43 kilocalories per day is their total daily energy requirement. All right. Next thing we did, so we did solution, or we did liquid. We did the total amount of energy, so the total amount of kilocalories they need. Now we're looking at protein requirements. So protein is an estimate. It's estimated based on the patient. You can see here if they are an unstressed patient, if they're most patients over 60, if they're critically ill, or if they have liver failure, they have different needs associated with that. So calculate the protein requirements for an unstressed patient weighing 63.64 kilograms. Unstressed patient is here, 0.8. So we need 0.8 grams of protein per every kilogram. The patient weighs 63.64 kilograms. Their total proteins that they need for the day, 50.912. This is grams per day. All right. Now, zoom back in there again. All right. The amount of proteins that the person gets is fine, but we don't give the person protein. We give them an injection of parenteral, in our case that we're looking at here. That is going to be in the form of an amino acid solution. The amino acid solution, right, for proteins typically ranges from anywhere about 5 to 10%. So the amount of kilocalories that protein source will give us is 4 kilocalories per gram. So every gram of protein will give us 4 kilocalories, right? We already discovered how to do the kilocalories that somebody needs per day right here, right? So if we know how much protein that they are taking, if it was 50.921 grams a day, we can take that from the total kilocalories of the day and find out how much that is being given by the amount of protein that we're giving the person. So if we have, excuse me, sorry. It says that, this example says, how many mLs of an 8.5% amino acid solution would be needed to supply the grams calculated in the above? And then how many kilocalories would that supply? So what this is asking is I'm going to show you a little picture here. So this is the way these solutions, not that one, this is the way that the solutions show up here. Solutions show up, as you can see, this Basal, which is a brand name product for amino acid injection. And notice it says 8.5% is what it is. So it's an 8.5% amino acid injection. It's not for direct infusion, and I'll show you a picture of that in a second, but this is the solution that we are going to be utilizing as a portion of the parenteral TPN. So the amino acid, so it's 8.5% amino acids, right? This means that there's 8.5 grams, right, for us in 100 mLs, right? So in 100 mLs of our solution. I'm going to write this just upside down to do our problem in this short space that we have here. This says, how many mLs would we need? So I know that there's 100 mLs is going to have 8.5 grams of protein. Why? Because 8.5% means grams per 100 mLs, or grams per something, and it's 100 something mLs. I need 50.912 grams. Why? Because it says in the question above. This is where we calculated the above. So if I multiply that out, I'm going to get about 598 point, let's say 96 mLs is what the amount of mLs that I would need of that 8% amino acid solution to give me 50.912 grams of protein. How many calories is that? Calories we're looking at is, remember, protein is 4 kilocalories. Yeah, hard to do the small stuff. There we go. 4 kilocalories per every gram of protein. I am giving 50.912 grams of protein. Right? This is per 1 gram of protein. So I'm going to multiply that out, and if I do that out, I get about 203.648, and that is kilocalories per day. Right? That's how many calories just the amino acid solution would give them per day. All right. So we did the amount of amino acids. Remember, we have amino acids, lipids, and the amount of carbohydrates that we'll do next. So those 3 macro. So let's do lipids next. All right, so for the lipid requirements, the lipids are going to be given in something that looks like this. This is an intralipid. It looks like a white milky substance. Lipids are fat, so fats are not going to dissolve in water. You need an emulsifying agent, so these are emulsified. The emulsifying agent, as well as the fat, is going to give some sort of energy to the system. So when we talk about lipids, let's talk about a few things. First is, what's the lipid requirement of an individual? It's usually 20 to 40% of their total calories that they need per day, or their total daily expenditure. So in this example down here, it says, if the total daily expenditure of a patient is 2,009.433 calories per day, right? How many calories should be from lipids? So you take this number, 2,009.43, and you multiply it by, right, 20 to 40%. Well, I'm telling you in this question, use 30, right? Right in between. So we're going to multiply this by 30%, or 0, you make it into the decimal there, 0.3, right? So 30% of that number. This is going to be about 602.829 kilocalories. That's how many calories should come from lipids. Now, the second question says, how many mLs of a 20% lipid emulsion would be needed to supply that daily amount? So here's the thing with lipids, something you have to memorize. For protein, when we did amino acids, it's 4 kilocalories per gram. For lipids, if you take it orally, it's 9 kilocalories per gram. So if you see something that's orally taken, lipids are 9 kilocalories per gram. But when we're given IV, you look at the percent concentration of the IV solution, and it'll tell you how many kilocalories per ml. That is shown sort of here. We have a 20%, right? And we can find out that, I'm going to scroll down here to our end here, in this little chart that's going to summarize everything we talk about. If it's given enteral, which means it's given by mouth, lipids are 10 kilocalories per gram. If it's given parenterally in these emulsions, right, it's 1.1 kilocalories per ml for 10%. It's 2 kilocalories for the 20%, and it's 3 kilocalories per ml for the 30%. So let's go back up to what that is. All right. So it says how many mLs of a 20% emulsion, which supplies 2 kilocalories per ml. That's where I'm getting that from. I'm telling you that. You don't have to memorize this. You do have to memorize the 9 kilocalories per gram, but not the emulsion ones. So how many mLs of the 20% will be needed to supply this amount of kilocalories, right? That's what the question's asking us. Well, we know for the emulsions, every 1 ml will supply us 2 kilocalories for the 20% emulsion. How many mLs if we want 602.829 kilocalories? It's about 300 and I believe 301.41, which is the amount of mLs like per day that the person can use of the lipids to supply the amount needed in terms of their calorie requirements from lipids. Last one is carbohydrates. Carbohydrates is all the remaining energy expenditures that we haven't, so all the amount of kilocalories that we haven't given to fats, right, to the lipids, as well as to the amino acids that are made up with the carbohydrates. And carbohydrates are the primary energy source, right? So that's how we would subtract the total daily energy requirements from all the ones that we've used so far. The remaining will always be the number of calories for the carbohydrates. We said that we use dextrose as our source for this carbohydrate. So dextrose solutions. We know 5% dextrose, but you can actually get up to 7%, 70% dextrose. So see the 70% dextrose, something you would never want to infuse directly into somebody's vein. But it's the most concentrated one, so when you're doing these parenteral solutions, it is one that we use a lot of. And you will notice that for parenterals, each gram of dextrose provides 3.4 kilocalories of energy. When you're giving it by mouth, it's 4 kilocalories. So the chart that I showed you below will summarize that. Remember, you want to know the kilocalories for proteins, carbohydrates, and lipids. Lipids, you don't have to know the ones for the emulsions that are given parenterally, but you should know the other ones. All right. So carbohydrates, 4 kilocalories per gram when given by mouth. Otherwise, it's 3.4. Let's look at an example. It says, how many grams of dextrose would be needed for a patient requiring 1,203 kilocalories per day from carbohydrates using your parenteral nutrition solution? So, how many grams of dextrose would be needed for a patient requiring this amount of kilocalories from carbohydrates? So, carbohydrates meaning from the dextrose. We know that parenteral dextrose gives us, right, 1 gram of that, 1 gram of dextrose gives us 3.4 kilocalories. If it was given by mouth, it would be 1 gram giving us 4 kilocalories. And this is 1 gram gives us this amount of kilocalories. We want 1,203 kilocalories. That tells us we need about 353.83 grams of dextrose, right? Of dextrose. How are we going to get that many grams of dextrose? Well, dextrose comes in a solution. So that's the second question. How many mLs of a 70% dextrose solution would be needed to give this amount of dextrose? What's 70%? We know that. We know 70% means that every 100 mLs is going to contain 70 grams of dextrose. All right. If I want 353.83 grams of dextrose, how many mLs is that going to be? It's going to be 505.47 mLs. Right? And that's the amount that would supply that. This right here is the summary of the nutritional needs that we just calculated, right? One thing just to keep in mind that if you look at a nutritional fact panel on the food, if you're drinking something, you're eating something right now, you have that nutritional fact panel, it's going to say calories. The calories listed there, right, is in kilocalories, not calories. So although kilocalories is abbreviated with a capital C, right, the actual calories is little c. So if it says calories and then it abbreviates with a C, that's talking kilocalories. So on a label, it's usually capital C, and that's the calories, meaning kilocalories. Okay, so if you're looking at total fluid, we know that it's 30 to 35 milligrams per kilogram. We know how to do the total calorie requirements per day, both for basal and total. We know that the total lipids is 20 to 40. Lipids give you 9 kilocalories by mouth, and you get different amounts when you're using the emulsions, which will be given to you. Proteins, always 4 kilocalories per gram regardless. The requirements may be different based on stress and activity of the patient, as well as total carbohydrates by mouth, which is enteral, 4 kilocalories per gram, parenteral, 3.4 kilocalories per gram. Those you should know. The bolded number you should know and have those memorized. All right. Now, the last thing we didn't do is an enteral. Enteral means giving it by mouth, but sometimes not only by mouth, I should say, it means it's giving it by the intestinal tract. So sometimes we'll bypass the mouth and we'll use a nasogastric tube that goes down the patient. Let me show you if I scroll on this here for a second. If you see here, this is a nasogastric tube, which is going to go into the person's nose, but it's going to go right into their stomach. So right into their gastrointestinal tract is where it ultimately goes. But it says liquid solution. So this is the enteral solution. This is going to be a pass through the tube and pushed in. This is that total parenteral nutrition that we were talking about. Those are given directly into a big artery because it will dilute the drug very quickly, because these are very hypertonic solutions. You can also give one peripherally, PPN, as well. Now, they are made in pharmacies. These are all the different solutions and electrolytes, but you will see a lot of these are usually going to be dextrose, amino acids, and your protein. When they're made, if they have fat in them, they look like this. If not, they are devoid of the lipids. You will see them as a yellowy sort of a color there. All right. So for enteral nutrition, which we didn't discuss yet, for enteral nutrition, a formula, so an enteral nutrition formula is packaged in 237 ml cans. So that picture that I kind of showed you here, let's say that this is the product. It's a can. That can, let's say, is 237 mLs. And each can on the label says it contains 71 grams of protein, 9.4 grams of fat, and 31.4 grams of carbohydrates. How many total kilocalories are supplied by that? This just uses the stuff that we were looking at in the chart. We're going to look at fat, carbohydrates, and then protein, right? We know fat. We know fat gives us how many kilocalories per gram? Fat gives us 9 kilocalories. Let me write it down here, sorry. 9 kilocalories. My goodness, I can do it. Kilocalories per gram. And it says that it has 9.4 grams of fat. So that number is 84.6 kilocalories are going to come from fat. The amount that comes from carbohydrates, now this is carbohydrates, but it is, as we see here, enteral. So it's 4. So this means that there is 4 kilocalories. 4 kilocalories per gram. And we are giving the person in that can 31.4 grams of carbohydrates. That's going to equal about 125.6 kilocalories from carbohydrates. And what about protein? Protein is always going to be 4 kilocalories. So protein is 4 kilocalories per gram, and we are going to be giving 7.1 grams, and that's going to be about 28.4 kilocalories. Altogether, all these are going to add up to about 238.6 kilocalories per can. Per 237 ml can. All right, so understand that there are different requirements as well as the amount of calories that are supplied by carbohydrates, proteins, and amino acids if they are given enterally or parenterally is important. All right, so these are the numbers. As always, this is Pharmaceutical Calculations, your most important course because it is the only one that counts.